Hi, my name is Felipe Rolim. I work at NOC Institute of Technology, INDT from Brazil. I'm here to talk about our project from prototype to final product. Uh, I have participated to create a real product prototyping using Arduino. So, why prototyping Arduino? Arduino is an open source platform, easy to learn and require very low background in electronics. The development software language is based on wiring, very similar to C and C++. This platform has a variety of open libraries and examples demonstrating how to use the sensors with significantly decrease the development time. These libraries may use to prove a concept very perform. Since the hardware platform is open, it can be modified to support going from a prototype to a commercial product. Sorry about my English. It's my first time speaking in English. Arduino having expansion slots, features boards, and sensors. So you can stack a lot of shields with many features and sensors. Here are some examples of shields: Ethernet, GPS, GSM, SD reader, Bluetooth, LCD keypad, relay shield module. With relay shield module, you can automate your house. And your wife will be crazy. Here are some sample of stacking shields. I never did that, but some people say that works. I don't know. Now, some open libraries. With these libraries, we can access the EEPROM Ethernet shield to connect to the internet, manipulate LCD, read and write SD cards, using serial communication. Here is a lot of open libraries. Everything is in your project was using open libraries. In this year, this project will be distributed with LGPR software and hardware. It's free. Now we make a GPS tracker. Why a GPS tracker? WWF called us about this problem. This is our motivating. Every year, many animals and humans being injured and killed due to human-animal conflicts. Main cause for the conflicts is the increasing loss of space available for the animals. Tracking devices may be used as tool to support this issue. Tracking device may provide more accurate information on animals' behavior, and also by allowing the emission of alerts when animals approach human settlements. Since mobile coverage is constantly increasing, especially near human settlements, and much more affordable than satellite transmission, this network is an interesting alternative for data transmission. And however, the current cost search device restricts the number of units available for researchers. The main motivation for an institute like INDT, NOC Institute of Technology, this type of project is provide a cheaper and open source tracking platform. Here's some news about this problem. WWF sent this to us. We investigated the similar products available in the market. Here, we investigated 3 products. The cheapest model here have some drawbacks, such as having a person in the field tracking device, subject to weather conditions and animal attacks. Many times the elephants kill people tracking them. Models with GPS, the last, and cellular satellite communication are usually very expensive, $5,000 and $10,000. We propose a solution. Since mobile coverage is constantly increasing, especially near human settlements, and much more affordable than satellite transmission, this networking is an interesting alternative for data transmission. Cheaper than satellite communications, don't need the people in the animal area to collect data. We evaluated some alternatives, creating our new hardware using a cell phone low end or a smartphone. The battery consumption is one of the main restrictions for tracking devices. Simplicity is also a main driver for the type of application, since the device will be unattended for a long time. We need this device in the wild for 2 years. Why we chose Arduino? Open source hardware platform, widely available open source libraries, easy to customize, firmware created for prototype can be easily evolved chosen on the final product. Other problem, the team didn't have previous knowledge about tracking system and hardware development. So used the following methodology: feasibility study, concept, prototype, and the final or product. We evaluated alternatives, we have showed to you, evaluate theoretical performance, create concept with key features, conduct initial assessments, and the other I will show after. Our concept, we bought some Arduino shields to create the concept. We used Arduino Uno with GSM, GPS, and SD reader. To visualize the data, we used the open source tool called OpenGTM, and the first proof of concept performed in less than 1 month. Our biggest problem was both the shields. In the Brazil, it's very expensive, both Arduinos. If in Europe you bought with 15 euros, in Brazil you bought, it's like 15 euros. It's very expensive. With the concept, we validate the main features, which was possible is to estimate the power consumption, removing unnecessary components such as voltage regulators, LODs, USB interface, etc. It was possible to validate the concept with project sponsors, WWF, as well as define the final specification. After validating our features, we decide to prototype our one board. Device designed with the following features. These features is to increase the battery in the wild, wake up every hour and check its schedule. Device in sleep state during the remaining time. Alternatives evaluate to send and receive data. SMS was chosen due to the greater coverage and lower power consumption. GPRS were chosen because there is no way to guarantee the SMS would be receiving the short awake period. This is our own hardware from prototype. The board was designed based on Arduino concept. Here, our own board, and here, GSM board, communicating with our own board. Remove unnecessary components, addition of components to turn off GSM and GPS while in standby mode to economy of battery. GSM should maintain it by time constraint and components availability. I talked to you. In Brazil, it's very difficult to buy this shield. Here, the prototype results. Device programmed to collect GPS data and send coordinates by SMS, tracking paths simulating real animal routes. collect data on the server compared with real data storage in the device. We store the GPS data with SD reader, SD card, sorry. We did these tests in the Nepal with WWF. Prototype results with this are first on board. GPS coordinates success rate above 18%. GPS fixed failed under dense canopy. SMS success rate lower than 15% size. SMS were sent even with low signal strength. After this test, we changed the send SMS only with its medium signal strength. Here, our final product. We removed the GSM shield and put the GSM chipset in our onboard. GSM, GPS, as the reader, all in the same board. It's the same components from Arduino board. It's the same chipset. GSM SMS components substituted by others with improved performance. GSM antenna substituted by an internal model, improved grounding for better GSM performance. 2 accelerator boards developed to enable access to SIM card and memory cards. It's the second board here. HDOP and RSSE evaluated before registering and sending. HDOP is horizontal precision from GPS. System modify internal schedule aiming at finding best times to wake up near cellular coverage area to make battery economy. Here we proposed enclosure. This enclosure we printed with a 3D printer. Now our on web application, we send this application to WWF. Here you can see the test on Nepal with HDOP. It's the green ball, green circle, sorry. With this web application, when the animal is near the human area, the system sends to people near an alert about the animals. Here our final product. It's a, oh, sorry.
Oh, you can achieve the workflow.
It's the last.
You still have 40 seconds for the workflow.
Okay. Here, since the concept to our final product. And here, this example of our web application. Again, our web application. And thank you.